Hey everyone, welcome back to Pine Hollow Auto Diagnostics. Today I wanted to do a quick follow-up on the Genie short crank case study where we replaced the Ignition Start Module, and some questions arose. Was that the actual problem? I mean, the Genie's starting fine. Since the module replacement, I haven't heard anything back from the construction company, so it's working, but I still felt kind of, it wasn't 100% conclusive proof that the module is at fault. So today on the bench we have the original start module here and some basic test equipment. So what I want to do is answer these questions. Why did we have the short crank? Can we reproduce it on the bench by manipulating the TACH signal? So this module is designed to, whenever you push the start switch, it engages the start relay, that's pin 1, and then as soon as it starts up, it's supposed to disengage that relay. So the starter doesn't, spin itself to death if the operator keeps the crank switch on. So basically what was happening when the Genie was not starting was you touch the switch and it kicks the starter in for a fraction of a second. It doesn't crank long enough to fire up and it doesn't start. Why is that? When we disconnected the TACH input and hit the start switch, that relay output stayed on. So a lot of people pointed out, Ivan, did you scope the TACH input? Yes, I did, not on video, but I checked it and it looked fine, and I guess I didn't remember to record that part. It's very important to check your inputs of the module before replacing a module. 100% agree with that. So let's look into what the TACH signal looked like when I started this thing up. So this is a successful startup, and when the Genie is running, you can see the voltage levels here are from -1 to about 16 volts, about 15.5. And when it's starting up, you can see that the level is rising, the frequency is increasing, and then this is the steady state output. Looks pretty good, right? So I'm like, hey, TACH signal's there. Why is this module shutting off the relay prematurely? Well, let's see if we can answer these questions. What does the TACH frequency have to be for the module to shut off the start relay? It has to be some threshold. What about the TACH amplitude? The lower and the higher thresholds for that square wave, what does the module need to see? And also, does the battery positive feed affect the operation of this thing? Obviously, it can't work on, if the voltage drops too low, as we saw during a starting event. Let's pick one here. So here are a few events where it didn't start. So this is just the voltage on the feed to the module, the B+, and we can see it drops to almost 7 volts. Is that too low? So this is the starter is engaged, and then the module shuts off the starter relay. Interesting to note that we can see some ignition pulses on here, so the engine's trying to start, but the starter is not held on long enough. During a successful start, right here, I still think that the start relay was not held in as long as it should have, but the engine actually caught and fired up. So from there to there, delta is 1.2 seconds. So that was enough to get it started. On the previous page, these starting attempts here, for example, that one was only half a second. Did not work. This one here, again, same thing, 400 milliseconds. did not start. This one right here, a little longer, still less than a second, but the Genie actually started up and ran. You can tell by the system voltage. So it started at 12.5, it cranked up, and then got up to 13.6. So let's do a couple experiments. I have the signal generator hooked up. We know what a known good TACH signal looks like. So I want to find these thresholds here in terms of the frequency and the TACH amplitude. And also we'll drop the feed voltage on our power source here. We'll just turn it down and see when this module actually shuts down. Alright, so the setup here, we have all these pins probed, and I have power going to pin 6 and 7. You can see the key switch is on. Don't worry about this number 8. I played around with it. That's just a bypass, so instead of the module turning on the ignition relay, it's jumped to number 7, so whenever you have the key on, it turns on the ignition. Again, it's kind of a not really important for this experiment, so we just have number 7 hooked to power. So you can see LED number 7's lit up, and now this is my power wire. This is like simulating the start switch. So we'll connect it here. Number 3 should light up, and number 1 comes on, and that's connected to my test light. So whenever the test light's on, it's just another indicator. That's basically when the starter should be spinning. So if we leave it like this, there's no TACH signal, this will stay on indefinitely. We proved that in the beginning of the diagnosis. Now let's turn on the signal generator. And see what the frequency is doing on the scope here. So this is live data, so we can adjust the DC offset here. We can adjust the output level. And I have the frequency graphed on the math channel. You see it's 107 Hertz. Just about what the screen is showing here. So experiment number 1 is, what does the frequency have to be for this start module to shut off the start relay? So I did some preliminary stuff, so I'll just show you. If the RPM signal is in this range from 2.2 volts to 3.1 volts, those are the thresholds that I found out experimentally, the frequency has to be increased to a certain threshold for the start relay to automatically shut off. Let's see when that is. And boom. 165 Hertz. So that's the answer to number 1, 165 Hertz on this TACH signal coming from the alternator. How did I get 960 RPM? That's the engine RPM. Alright, so we just saw that the start module shuts off the relay when the TACH signal is over 165 Hertz. Remember that number, 165 cycles per second. Now, what is the engine RPM for that TACH signal? Well, it would have been easier if I had 2 channels hooked up when I did the TACH signal, when I actually cranked it. So this is our TACH signal. So we just pick a point, it starts up, runs for a couple seconds. Let's just get in here, and just by using the cursors right there, we see that we're at 330 Hertz. So remember that number. Go back here, this is our voltage feed and our current going through the main circuit breaker. And it's pretty cool, we can see ignition pulses on here, and that's how we can get the RPM from this capture. So 2 firing events for 1 crankshaft revolution. So we'll put our cursors on there, and this thing is saying the engine is running at 1,600 RPM, which is believable. You know, that's what it sounded like. It wasn't a low idle, it was just, you know, like low speed. So with those two numbers, you have 1,600 RPM, and you know, depending on where I measured, I actually got 2 measurements. So let's just use 330 hertz. You know, the RPM TACH signal is 330, and the engine spinning at 1620 RPM in hertz. So the equation, we just wanted this factor. The RPM is equal to the alternator hertz times 4.9 if we use 330. So just divide 1620 by 330, you get 4.9. And then this magic number, 165 hertz, the RPM will be 165 times 4.9. So 165 times 4.9, about 800 RPM. If you use the other number, you get 950. So somewhere in there, as the engine RPM crosses that threshold, the start module shuts off the relay. That's how it's supposed to work. That's reasonable. We demonstrated that that's exactly how it's working right now. Let's just try one more time. And also, if there's any TACH signal on here and you try to start it, you can see right now it's running because 9 is on. It will not engage the start relay. It's a smart system. However, if we disconnect the TACH signal, boom, 9 shuts off instantly. Let's try to start it again. Starter relay engaged. And now, if the TACH signal is lower than 165, the starter relay will stay engaged until we get past the magic 165. Okay, that's question number 1. Other question is, these thresholds, how did I get 2.2 and 3.1 volts? That's just by playing around with this DC offset button. So if we, let's say, you know, the signal's down here and it's above the threshold, okay? Start relay's on. As we turn up the DC offset and this signal rises, the top point will have to get over that top line in order for the light bulb to turn off. We can demonstrate this. So I'll turn up the, let's see, the DC offset. You'll see the scope and the light bulb. And, oh, it just shut off. Let's try again. Light bulb's on. DC offset. Boom. Right there. Same thing goes for if your signal's too high. Again, light bulb's on. Now we have to bring the DC offset down until it crosses that lower line. Light bulb turns off. So that answers our second question. The TACH amplitude, the high has to be greater than 3.1 volts and the low has to be lower than 2.2. This module is just looking for that transition through this range and counting the number of transitions per, per second, or the actual frequency. So we have our frequency, we have our TACH requirement, the amplitude, and now let's see what happens when we turn the feed voltage down to this module. When does it shut off? So I'm going to disconnect the TACH signal and just crank it. So we're pretending we're cranking here. I'm going to turn down this voltage on my power supply, and the measurement has to get below 6.3 volts this module to actually shut down. Keep looking at the LEDs. It's starting to kind of go crazy there. We're at 6.1 volts. But even if the voltage drops and it shuts down, we can bring it back in the same state. So everything here points to this module being, it's doing what it's supposed to by design. Why the heck does it not hold the starter relay in on the Genie? So check, check, check. Let's go back and take a closer look at the TACH signal and see during that initial start, the first few revolutions as it's ramping up, are any of these conditions not met? Okay, so this is the only capture of the TACH signal that I have, and I wish I got one during a non-successful start. So this was a successful start when the thing actually fired up. Well, let's take a look at this TACH signal as it's ramping up. So once it starts up, it looks pretty decent. Nice square wave, about 0 to 16 or minus 1 to 16 volts. Looks pretty nice. However, during startup, the amplitude's lower and it's kind of noisy. It's not really a square wave. My question is, can this confuse the module and make it think that we're running faster than it actually is? I think that's the only variable left, is this TACH signal is not what it should be during startup. So let's set those voltage lows again from 2.1 to 3.1 volts, right around there. That's what the module is looking for. If the signal crosses that threshold, it'll count it as, that we have a TACH signal. So, for example, if this first part is, it's kind of like garbage, but it's right in that sweet spot, right in that threshold. Could that possibly be confusing the module and causing it to say, hey, we're running really fast now, I'm going to shut off the starter relay? Because, electronics doesn't really care. There's no timer in there. It's just looking for a proper RPM signal. And, in half a second, all this stuff happens. Stuff like this. Now again, this happened on one of the pulses, but if it's seeing so many transitions through this key zone, would it potentially shut down the starter relay and not let it, fire up? I think that's the only possible culprit to this thing. And then you ask, well, why did the new module work better? It seems to be starting every day. It might have better noise filtering on that circuit. It wasn't an OEM, Genie module, it was this aftermarket one. But otherwise, this original module seems to be doing what it should. The suspicion here is that this TACH signal is kind of crappy. So then it's confusing the module. So you guys are absolutely right. you have to look at the TACH signal, and well, I did, but not this in depth. I mean, this is a bench test. We have some time here. We can sit down and think about it. On the construction site, I hooked it up, fired it up, like, hey, we have a TACH signal, okay, we're good. Well, not necessarily. That's not necessarily the case. So appreciate everyone watching. Really sharp people in the comments. Love it. Love the discussion. Stay tuned for more. We'll see you next time. Bye-bye.